Welcome to Greco AIA Continuing Education Series. Today's course is Coatings and Finishes for Architectural Metal Products, created and presented by Greco Architectural Metal Products. Greco is an AIA provider. Before we start, I like to give some background on Greco. Greco is part of CSW Industrials, a diversified industrial growth company with well-established scalable platforms and domain expertise across two segments: industrial products and specialty chemicals. Greco was founded in 1991 in Windsor, Ontario, Canada. Greco designs, engineers, manufactures, and installs architectural railings and metal products throughout Canada and the United States. The company's success is attributed to innovative designs, outstanding customer service, and unparalleled technical support. Whether for new construction or restoration projects, Greco's architectural railings and metal products have become the first choice of building owners, general contractors, engineers, and project specifiers. The company has offices and fabrication facilities in Hudson, Florida, and Windsor, Ontario, Canada. Here is our AIA Best Practices Statement. CSWI is a registered provider with the American Institute of Architects Continuing Education Systems. Credits earned on completion of this program will be reported to CAS records for AIA members. Certificates of completion for non-AIA members are available on request. This program is registered with the AIA-CES for continuing professional education. As such, it does not include content that may be deemed or construed to be an approval or endorsement by the AIA of any material of construction or any method or manner of handling, using, distributing, or dealing in any material or product. Questions related to the information within this program should be directed to Greco Architectural Metal Products upon completion of this program. This presentation is protected by U.S. and international copyright laws. Reproduction, distribution, display, and use of the presentation without the written permission of the speaker is prohibited. This course will cover the type of coatings or finishes that you select for architectural metal products that include railings and how they can directly affect the look, performance, and longevity of the product. This course will help you understand the differences between powder coatings, liquid coatings, and anodized finishes. The course will discuss coating technologies, performance testing, product evaluation, and product specification. Today's course objectives include the following. First, we will describe powder coating's performance, aesthetics, and key features. Second, we will describe liquid coatings, performance, aesthetics, and its key features. Third, we will discuss performance, aesthetics, and key features for anodized finishes. Fourth, we will review the ASTM testing standards and performance criteria for coatings and finishes. And fifth, review coating specifications and selecting the right finish based on the project requirements, environment, and performance. This course is intended for educational purposes only. The research, images, and information gathered for this course came from a variety of online resources and from various companies to offer an in-depth educational presentation. For your specific project needs, please work directly with your railing fabricator or manufacturer to get the most accurate and up-to-date information. Coatings and Finishes for Architectural Metal Products is another Greco AIA continuing education course, helping architects and designers better understand commercial railings and metal products. Now let's move on to the course presentation. This course is designed to explore the world of metal coatings and finishes for architectural metal products and provide a basic overview of performance, appearance, and design considerations. So the question is, why should you care about metal coatings and finishes? Well, the fact is, architectural metal coatings and the type of finish are critical in the design and product selection process for architectural metals, which includes architectural railings. In this presentation, we've included finishes for anodized metals. Although these finishes are different than an applied coating, we are grouping them together as the design consideration process is the same. Coatings are designed to help protect, enhance, and extend the lifespan of any metal surfaces associated with a building or the building's design. The right coating can also contribute to sustainability and reduce maintenance costs over time. Metal coatings play an integral part in the overall construction and design, offering durable and visually appealing surfaces for railings and other architectural metal products. Metal coatings, regardless of the product, serve several important purposes and should be a critical design feature on any commercial project. These four essential purposes are protection, aesthetics, durability, and sustainability. When we talk about protection, we are talking about a protective layer that shields metal surfaces from environmental elements such as moisture, oxidation, and UV rays. This protection can prevent corrosion and extend the lifespan of the metal and minimize maintenance of the metal product. With aesthetics, there's an expansive range of colors and finishes that can enhance the appearance of a building. Coatings can be customized to match the design scheme and create a consistent look throughout the building. Durability addresses the performance of the metal surface by adding a layer of hardness or resistance to abrasion. This can help prevent damage from impact or wear and tear. And then we have sustainability, which addresses the impact on the environment. Coatings can be formulated to minimize VOCs and reduce harmful waste. To bring some perspective to the topic of architectural metal coatings, let's take a look at the most common products, some of the key players in the industry, and in the architectural markets where coatings for metals are most critical. Let's start with products. So what are we talking about when we say coatings or finishes? There are several types of metal coatings available. The three most common that we will discuss in this presentation are powder coatings, liquid coatings, and anodized finishes. Although anodized finishes are not actually a coating, it offers the same design considerations, and for the purpose of this presentation, we have included these finishes in our coatings discussion. Each coating and finish has its unique properties, features, benefits, and limitations. Selecting the right coating or finish for your project requires an understanding of the specific requirements and conditions. We will start with an overview of the product categories and then go into greater detail of each product and then compare the coatings or finishes based on design needs and project requirements. So let's start with powder coatings, a popular choice for their durability, versatility, and environmental benefits. They consist of finely ground particles of pigment and resin that are electrostatically charged and then sprayed onto the metal surface. Once applied, the coating is cured in an oven, creating a hard, durable finish that resists chipping, fading, and corrosion. Then we have liquid coatings, which is applied in a wet state using brushes, rollers, or sprayers. Liquid coatings are available in a wide range of colors, textures, and finishes and offer excellent adhesion. Liquid coatings can also be formulated to meet specific performance requirements, such as resistance to chemicals, abrasion, or UV exposure. And last, we have anodized metals, which is not a coating but an electrochemical process that forms a protective layer of oxide on the metal surface. This layer enhances the metal's natural properties, such as corrosion resistance, hardness, and color stability. Anodized finishes are commonly used in architectural applications due to their durability, low maintenance requirements, and aesthetic appeal. So, who are the players in the architectural metal coatings market? There are several major manufacturers of architectural metal powder coat and liquid coatings in the United States. Some of the leading companies in this industry include PPG Industries, a global leader in coatings and specialty materials, including architectural metal powder coat and liquid coatings. The company's product line includes a wide range of coatings for various architectural applications, such as building facades, metal roofing, and aluminum extrusions. Tiger Drylac is another well-known company that specializes in manufacturing high-quality powder coatings for a wide range of applications. The company offers an extensive range of powder coating products with various formulations and finishes to meet the diverse needs of the architectural market, as well as other industries such as automotive, furniture, and appliances. Sherwin-Williams is one of the largest manufacturers of architectural coatings in the United States. The company offers a broad range of products, including powder coatings, liquid coatings, and specialty coatings for various metal substrates. AkzoNobel is a global leader in the production of coatings and specialty chemicals. The company's product line includes a range of powder and liquid coatings for architectural applications such as metal cladding, curtain walls, and window frames. Axalta Coating Systems is a leading manufacturer of coatings for various industrial and architectural applications. The company's product line includes a range of powder and liquid coatings for metal substrates, such as aluminum, steel, and zinc. Valspar is a subsidiary of Sherwin-Williams and offers a range of architectural coatings, including powder coatings and liquid coatings for metal substrates. The company's products are used in a variety of applications, such as metal roofing, cladding, and curtain walls. Metal coating products are used in a wide range of architectural applications. Some of the most critical commercial architectural markets for metal coatings include building facades, roofing, structural components, and railings. These are all applications that can be exposed to extreme conditions, and high-performance coatings are critical to the longevity of the product. Of course, metal coatings, to various degrees, are used on essentially all metal products in both interior and exterior applications. As mentioned, architectural coatings and finishes are applicable to all metal products. However, it is a critical design element in commercial railings, as railings, more so than other products, are not only exposed to the elements, but also has direct contact with people. Let's take a quick look at commercial railings and the importance of the right coating or finish. For commercial railings, we are primarily looking at aluminum or steel, with aluminum being the most popular related to the overall volume in the United States. Here are some of the key areas that can determine the right coating. Material selection. The selection of aluminum or steel for commercial railings can depend on factors such as cost, strength, and durability. Aluminum is a popular choice for its lightweight and corrosion resistance, while steel offers greater strength and durability. Building code requirements. Building codes may require coatings on railings for performance and safety reasons. For example, coatings can provide slip resistance, protect against corrosion, and improve visibility. The specific coating requirements can depend on the location and environment of the railing, as well as the applicable building codes. Performance requirements. The selection of a coating can depend on the performance requirements of the railing, such as durability, weather resistance, and color retention. Coatings can provide a range of performance properties, and the specific coating selected can depend on the desired performance and cost. Aesthetics. The appearance of the coating can also be an important factor in the selection of a coating for railings. Coatings can provide a range of colors and finishes, and the specific coating selected can depend on the desired aesthetic effect. Overall, the selection of a coating for railings can depend on a range of factors, including material selection, building code requirements, performance requirements, and aesthetics. Careful consideration of these factors can help ensure that the coating provides the necessary performance and appearance for the railing application. As we go into more detail for each of the coatings, one of the most critical design features is the performance of the coating or finish. The industry standard is the American Architectural Manufacturers Association, or AIA, coating specifications, which apply to both liquid and powder coatings. The three coating performance specifications are 2603, 2604, and 2605. However, we will focus on 2604 and 2605 as these are the two desired standards for exterior metal coatings. The anodized finishes are different than powder or liquid coatings, so it falls under its own specification, AAM A611. Keep in mind that although these specifications are the industry standard for coatings and finishes, they are voluntary and not mandated unless specified. So let's take a look at each of these specifications. 2604 is a mid-level performance standard for architectural coatings. It is suitable for exterior applications in moderately harsh environments. These coatings are often applied to storefronts, windows, doors, and low-rise curtain wall applications. Many designers will also specify 2604 for interior applications as well for the overall increase in performance. And then we have 2605, which is the highest standard for organic coatings, designed for use in harsh environments such as coastal areas or areas with high levels of pollution. It measures the same properties as 2604, but has even stricter requirements for color and gloss retention, as well as resistance to erosion, chalking, and fading. 2605 is the highest level of performance for architectural coatings. It is suitable for exterior applications in severe environments, such as coastal areas or regions with high levels of UV exposure. This standard requires coatings to meet the most stringent performance requirements, including excellent resistance to fading, chalking, and erosion, as well as long-term color retention. Overall, these standards provide a way for manufacturers and architects to ensure that coatings for aluminum extrusions and panels are durable and reliable and will meet the demands of the environments in which they will be used for. Many manufacturers will base their warranties on these standards as well as other criteria. It's best to work with your trusted railing or building product manufacturers to make sure you specify the best coating for your project and the related warranty that is provided. Remember, anodized metal finishes are not a coating, so the paint standards of 2603, 2604, and 2605 don't apply. The performance standard for anodized finishes is 611. The test involves subjecting the anodized finish to a series of tests to assess its durability, including resistance to abrasion, impact, and weathering. The goal is to ensure that the anodized finish meets the performance standards required for architectural applications. Anodized finishes are classified into two classes. A Class 1 anodized coating is a high-performance finish used for exterior building structures and other products that must withstand continuous outdoor exposure. Class 1 anodized is more resistant to salt spray and the seacoast, and it is more durable in high-traffic areas. A Class 2 anodized coating is recommended for interior applications or light exterior applications receiving regularly scheduled cleaning and maintenance such as storefronts and entranceways. Class 2 anodized is not as durable or wear-resistant as a Class 1 finish. So now, let's get into the types of coatings, what they are, and where they should be used. Organic coatings refer to a wide range of paint and powder coating systems used for architectural applications, such as coating metals, plastics, and other substrates for aesthetic, protective, or functional purposes. Organic coatings for architectural metals typically consist of a combination of resins and pigments. The resins bind the pigments to the substrate and provide protective properties. Resins can range from 25 to 70% of the coating's makeup. Pigments, as you may have guessed, provide the color but also provides hiding attributes and chemical resistance. Pigments vary in its makeup from no pigments up to 50%. Solvents are used in liquid coatings only and are the vehicle by which the solids are transported to the substrate. Solvents in liquid coatings can range from 40 to 60% of the total makeup. And then we have additives. There are a variety of additives that can be added to coatings, depending on the intended application and desired performance. Let's take a closer look at these critical ingredients. Pigments are an important component of organic coatings for architectural metals. Pigments are used to provide color, hiding power, and other desired properties to the coating. Inorganic pigments such as titanium dioxide, iron oxide, and zinc oxide are commonly used in organic coatings for architectural metals. The primary function of pigments in organic coatings is to provide color. Pigments are finely ground particles that are mixed into the coating formulation to give it the desired color. The amount and type of pigment used can vary depending on the specific color and opacity required. In addition to providing color, pigments can also enhance other properties of the coating, such as durability, chemical resistance, and UV stability. For example, some pigments can improve the resistance of the coating to fading, chalking, or weathering, which can help maintain the appearance of the building over time. Pigments can also affect the performance of the coating in other ways. For example, some pigments may provide resistance to corrosion or chemical attack, while others may enhance the hardness or abrasion resistance of the coating. Overall, the pigments used in organic coatings for architectural metals play a critical role in determining the final color, performance, and appearance of the coating. The selection and use of pigments must be carefully considered to ensure that the coating meets the desired requirements and performance properties. Our other critical component is resins. Resins are a critical component of organic coatings for architectural metals. Resins are the primary binder in the coating, holding the pigments and other components together and adhering the coating to the metal substrate. The specific resin used in an organic coating can vary depending on the intended application and the desired performance properties of the coating. Common resins used in organic coatings for architectural metals include acrylics, polyurethanes, epoxies, and polyesters. Resins play several important roles in the performance of organic coatings for architectural metals that include adhesion, film formation, durability, and the overall appearance. Resins are responsible for adhering the coating to the metal substrate, ensuring that the coating does not peel or flake off over time. Resins are responsible for forming a continuous film on the surface of the metal, ensuring that the coating provides complete coverage and protection. Resins contribute to the overall durability and performance of the coating, providing resistance to UV radiation, weathering, chemicals, and other environmental factors. Resins can influence the gloss and appearance of the coating, providing a high gloss or matte finish, or other desired aesthetic properties. Overall, the selection and use of resins in organic coatings for architectural metals is critical to ensuring that the coating meets the desired performance and appearance requirements. The specific resin used, as well as the formulation and application method of the coating, can have a significant impact on the performance and durability of the coating over time. Next, we have solvents. As mentioned earlier, solvents are unique to liquid coatings. In powder coatings, there are no solvents used in the formulation or application process. In liquid coatings for architectural metals, solvents are used to dissolve the resin and other components of the coating, making it easier to apply and ensuring that it forms a smooth, even film. The solvent is also responsible for controlling the viscosity of the coating, making it easier to apply with a brush, roller, or spray gun. Solvents can also control the drying time of the coating, ensuring that it dries at the desired rate and does not sag, drip, or run. However, the use of solvents in liquid coatings for architectural metals has decreased over time due to environmental regulations and concerns. Many coatings manufacturers have reduced or eliminated the use of solvents in their formulations in order to meet environmental and health regulations. Instead, they have developed solvent-free or water-based coatings that provide similar or improved performance properties. Overall, the use of solvents in liquid coatings for architectural metals is important for achieving the desired application properties of the coating. However, the selection and use of solvents must be carefully considered to ensure that the coating is effective and environmentally responsible. So let's take a deeper look into metal powder coatings. These coatings are widely used in architectural projects due to their excellent properties, such as durability, corrosion resistance, and aesthetic appeal. The manufacturing process with powder coatings begins with the preparation of the metal substrate by cleaning and pre-treating it with chemicals to enhance adhesion. The next step is to apply an electrostatically charged powder coating onto the metal substrate. The powder is sprayed onto the substrate, and it adheres to the surface due to the electrostatic charge. After application, the coated metal substrate is cured in an oven, where the powder melts and forms a uniform and durable coating. Powder-coated metal products are a versatile option for a wide range of architectural applications. Some of the most common architectural applications for powder-coated metal products include building facades, window frames, railings, and handrails, and decorative metals, to name a few. Powder coatings are a popular choice for architectural metal products due to their many advantages over traditional liquid coatings. Let's go over a few of these key benefits. First, we have the overall durability. Powder coatings are highly durable and provide excellent resistance to corrosion, weathering, chemicals, and UV radiation. They can withstand harsh outdoor environments and maintain their color and appearance for many years. Next, we have sustainability. Powder coatings are a more sustainable option compared to liquid coatings, as they contain no solvents and emit no VOCs. This makes them environmentally friendly and safer for human health. Powder coatings are also very cost-effective. Powder coatings can be a cost-effective option for architectural metal products, as they can be applied in a single step and require less maintenance over time than liquid coatings. They also generate less waste, as unused powder can be reclaimed and reused. Another feature is the aesthetic flexibility, providing a wide range of colors, textures, and finishes, allowing for greater aesthetic flexibility and customization. They can also provide a smooth, uniform finish without runs, drips, or sags. Powder coatings are also very efficient in the fact that it can be applied in a single step and cure quickly, reducing production time and increasing efficiency. Although powder coatings for architectural metals offer many advantages, they also have some limitations that should be considered before selecting them for a specific application. One of the limitations includes the thickness of the coating. Powder coatings are typically limited to a maximum film thickness of 2 to 4 mils per coat. For thicker coatings, multiple coats may be required, which can increase production time and cost. Another limitation has to do with the application process. Powder coatings require specialized equipment for application, including electrostatic spray guns and ovens for curing. This can require additional capital investment and training for personnel. Color matching is another limitation for powder coatings. Although powder coatings offer a wide range of colors and finishes, color matching can be challenging due to variations in batch-to-batch production and the effect of curing temperature on color. Overall, the limitations of powder coatings for architectural metals should be carefully considered before selecting them for a specific application. While powder coatings offer many advantages, they may not be suitable for every application or substrate. Let's talk a little bit more about colors. Powder coatings offer a wide range of color options for architectural metal products. The color options available can depend on the specific formulation of the powder coating from the manufacturer. Some common color options for powder coatings include solid colors, such as white, black, gray, blue, green, red, and yellow. These colors can have a matte or glossy finish and can be customized to meet specific color requirements. You can also get powder coatings formulated to produce metallic finishes, which can provide a glossy, reflective surface with a metallic appearance. Metallic finishes can come in a variety of colors, including silver, gold, bronze, and copper. Additionally, if you are looking for textures, powder coatings can be formulated with a variety of textures, including matte, satin, and textured finishes. These finishes can add depth and visual interest to the coating and can be customized to meet specific aesthetic requirements. If you are looking to simulate a wood product, you can formulate a powder coating to mimic the appearance of natural wood grain, providing a more natural and organic look to your metal products. And you can also get custom colors. Many manufacturers of powder coatings can provide custom color options, allowing architects and designers to specify a unique color for their project. Overall, powder coatings offer a wide range of color options for architectural metal products, providing flexibility and customization in design. So, is powder coating the right product for your project? As an architect, you should carefully evaluate the advantages and limitations of powder coating architectural metal products to determine if they are the right choice for your project. When considering the use of powder coatings, you should consider factors such as the performance requirements of the coating, the aesthetic goals of the project, and the budget and schedule constraints. You should also consider the environmental impact of the coating, as well as the potential limitations and challenges associated with its application. To make an informed decision, you may want to consult with a coatings expert or supplier who can provide more information on the specific advantages and limitations of powder coatings for your particular application. Ultimately, the decision to use powder coatings should be based on a careful evaluation of the project requirements, the available options, and the desired outcomes. It is worth noting that powder coating is available to meet the 2605 standard. Although this is not common due to the increased cost, it is an option with some manufacturers. Let's talk about warranties for powder coatings. Warranties are not the same from every manufacturer or supplier, as they can vary in length and coverage depending on the specific product. Warranties for powder coatings typically cover defects in the coating such as chalking, fading, peeling, or cracking. Some warranties may also cover the cost of replacement or repair of the coating, while others may provide a prorated refund of the cost of the coating. The length of the warranty can vary depending on the specific product and manufacturer, but may range from several years to several decades. Some manufacturers may also offer extended warranties or other coverage options for an additional fee. Whether or not you need a warranty for your powder coating depends on your specific project requirements and budget. A warranty can provide peace of mind and protection against defects or premature failure of the coating. However, It is important to read the warranty carefully and understand its limitations and exclusions. In addition to warranties, you may also want to consider other factors when selecting a powder coating for metal products, such as the performance properties, the environmental impact, and the availability and cost. Let's take a look at a few Greco projects to illustrate the versatility and applications of powder-coated metals. This project is the Village Town Center in Dallas, Texas, a mid-rise condo building. Here you see a custom decorative railing systems with powder-coated panels. The building also has an integrated glass railing system where the frames are powder-coated. There's also a metal trellis over the top balcony that also has a powder-coated finish. This project is Frenchie's Saltwater Grill on Clearwater Beach, Florida. This is a great example of using custom colors with a gloss finish, creating a custom and unique look to the restaurant's outdoor seating area. Staying on Clearwater Beach, down the street is Krabby Bill's. There's a variety of interior and exterior architectural metal products on this project that include railings, decorative panels, and custom signage. So now, let's look at liquid coatings. The liquid coating process for architectural metals is a multi-step process that involves the preparation of the metal surface, the application of a primer, top coat, and clear coat, and the curing of the coating through baking in an oven. This process ensures that the metal product is protected from environmental damage and provides the desired aesthetic appearance. The use of a 5-stage pre-treatment process, in combination with the primer and top coat, provides the necessary adhesion and corrosion resistance for the liquid coating to adhere to the metal substrate and maintain its appearance for an extended period of time. Here are the steps to the liquid coating process. The metal surface is first cleaned through a 5-stage pre-treatment process, which includes cleaning, rinsing, etching, a second rinse, and then a final rinse. This process ensures that the metal surface is free of contaminants and provides a suitable surface for adhesion. The metal is then dried in an oven to remove any remaining moisture from the surface. A primer coat is then applied to the metal surface to provide a base layer for the subsequent coats. The primer enhances adhesion and provides additional corrosion resistance. Then a top coat is applied over the primer to provide the desired color, gloss, and performance properties. The top coat can be customized to meet specific design requirements and can be a single coat or multiple coats. A clear coat may be applied over the top coat if desired to provide additional protection and enhance the appearance of the finish. The coated metal is then baked in an oven to cure the coating and ensure that it adhered to the metal surface. This multi-step process includes surface preparation, primer, top coat, clear coat, and baking in an oven. Liquid coatings offer a superior coating to architectural metal products and is the product of choice to meet AIA 2605. As discussed earlier, 2605 is the highest level of performance for architectural coatings. It is suitable for exterior applications in severe environments, such as coastal areas or regions with high levels of UV exposure. Liquid coatings offer superior performance in weatherability, UV resistance, corrosion resistance, film integrity, impact and abrasion resistance, and color and gloss retention. Applications of architectural metal products with liquid coatings for the exterior include product for the building facade, such as metal panels, cladding systems, and curtain walls. Liquid coatings enhance the building's aesthetics while providing protection against the elements. Metal roofing is another application offering weather resistance, UV protection, and insulation properties. Structural and safety applications include railings, guardrails, columns, beams, and trusses, ensuring both visual appeal, structural integrity, and protection from harsh environments. The benefits of using liquid coatings for architectural metal products include design flexibility, customization, sustainability, and it's cost-effective. From a design standpoint, liquid coatings offer a wide range of color options, finishes, and textures, allowing architects to achieve their desired aesthetic vision. Liquid coatings can also be customized to match specific design requirements, enabling architects to create unique and eye-catching metal products. Today, many liquid coatings are formulated with low or no volatile organic compounds, contributing to sustainable building practices. And lastly, liquid coatings are very cost-effective solutions for protecting and enhancing architectural metal products, reducing long-term maintenance and replacement expense. Additionally, liquid coatings have no sizing constraint, where powder coatings require large parts fit into the curing oven. Equipment required to spray liquid coatings is typically less expensive than equipment required to spray powder coatings, including the oven. And it's also worth noting that it is much easier to color match liquid coatings than powder coatings in the field when repair work is needed. There are also some limitations worth noting with liquid coatings. Let's start with application constraints. Liquid coatings require careful application to achieve a smooth, even finish, necessitating skilled labor and controlled conditions. Curing time can also be a limitation for liquid coatings. Depending on the manufacturing conditions and application method, the curing time can range from a few hours to several hours, which may impact the project timelines. Substrates could also be a concern, as some substrates may not be suitable for liquid coatings due to their composition or surface texture. For most architectural metal products, this is not an issue, but worth noting. Similar to powder coatings, liquid coatings offer a vast array of solid colors, ranging from vibrant hues to subtle neutrals. Liquid coatings can also create metallic effects as well as textured finishes, providing depth and tactile qualities. Custom color matching is also possible. Many manufacturers offer custom color matching services, allowing architects to achieve precise color coordination within their projects. Liquid coating warranties are provided by manufacturers and can vary greatly. The intent of the warranty is to assure the performance and durability of their coatings. These warranties typically outline the coverage provided, limitations, and conditions under which the warranty is valid. These warranties typically cover defects of the material such as peeling, cracking, blistering, fading, and corrosion of the coating. The warranty period of coverage can vary greatly from manufacturer to manufacturer. There are many limitations that are written in a warranty. Make sure you understand what these are and how it impacts the warranty. Whether a liquid coating warranty is worth considering depends on several factors, including project requirements and the manufacturer's reputation. There should be a cost-benefit analysis that assesses the cost of the warranty versus the potential risks and expenses associated with coating failures or premature deterioration. Let's take a look at a few Greco projects with liquid coating metal finishes. This project is Bellevue Place, a mid-rise condominium in Bel Air, Florida. Here we have a traditional glass and aluminum railing system painted white. This condo is less than a mile from the Gulf of Mexico, and the coating meets the 2605 performance standard to deal with the harsh environment conditions. Our next project is Omega, a high-rise condominium in Bonita Bay, Florida, near Naples. This project is also near the water and has a glass and aluminum railing system. Kynar liquid coating was used on the aluminum to meet the 2605 standard. The Fairfield Inn on Clearwater Beach, Florida is a great example of using liquid coatings for multiple applications meeting the performance criteria of 2605. This project has custom railings, sunshades, and other architectural metal products throughout the project. Now we're going to take a look at anodized finishes. Whereas liquid and powder coatings apply a paint to the metal surface, anodizing is a process that is used to create a protective layer on the surface of a metal that is usually aluminum. The manufacturing process of anodizing involves several steps. The first step, and the most critical step, is cleaning the metal to remove any dirt, grease, or other contaminants that may be present. The metal is then placed in a chemical bath and an electrical current is applied. This causes the metal to oxidize and creates a layer of aluminum oxide on the surface. The thickness of the oxide layer can be controlled by adjusting the electrical current and the duration of the process. Anodized metals can be a great option for architects looking for durability and weather resistance with a metallic or unfinished metal look that offers low maintenance. While AMA 2605 is a widely recognized standard for organic coatings, AMA 611 specifically addresses anodized finishes as we had referenced earlier. AMA 611 focuses on anodized finishes and specific tests that focus on corrosion resistance, abrasion, and color uniformity. 611 does not specify requirements for UV resistance or weatherability, as anodized finishes inherently provide excellent performance in these areas. Anodized finishes are commonly used in architectural applications due to their durability, corrosion resistance, and aesthetic appeal. Some common architectural metal applications for anodized finishes include railings and guardrails, windows, curtain wall, window wall, in storefronts, and roofs. Essentially, any exterior architectural metal product could have an anodized finish. Using anodized metals has many benefits, including enhanced aesthetics, durability, low maintenance, and sustainability. For aesthetics, anodized finishes provide a sleek, uniform appearance with a range of metallic tones and finishes, adding a sophisticated and modern look to architectural designs. Anodized finishes provide excellent resistance to corrosion, weathering, and fading, providing a durable and long-lasting solution for architectural metal products. Low maintenance is a key benefit for anodized metals, as it requires minimal maintenance. They are highly resistant to scratches, abrasions, and stains, reducing the need for frequent cleaning or touch-ups. Anodized metals are also environmentally friendly, as the anodizing process does not involve the use of volatile organic compounds, and the finished product is fully recyclable. There are some limitations to anodized metal finishes as well, namely color options, as typically the finishes are metallic tones, with limited colors compared to organic painted coatings. Surface preparations can also be problematic if not done correctly, as it requires careful cleaning and treatment of the metal substrate. One other limitation or potential issue with anodizing metals is once the metal is anodized, it is difficult to modify or repair the finish without stripping and re-anodizing the metal, making alterations or touch-ups more complicated compared to painted coatings. Anodized finishes for architectural metals are highly durable, corrosion-resistant, and customizable. They are a great choice for architectural applications where longevity, aesthetics, and low maintenance are important factors. Warranties for anodized finishes typically cover material defects such as peeling, cracking, blistering, fading, and corrosion of the anodized finish, ensuring product durability. As with most warranties, the duration of coverage varies by manufacturer. Architects and owners should conduct a cost-benefit analysis to determine the value of the warranty for their specific project need. Evaluating potential risks and expenses associated with coating failures or premature deterioration is crucial. As we have said before, partnering with reputable manufacturers is highly recommended, as they are more likely to offer reliable warranties and stand behind their claims. Anodized finish warranties can provide a peace of mind and minimize disruptions and unexpected expenses due to defects. Let's take a look at a few Greco projects with anodized metal finishes. Here's a high school in Kissimmee, Florida that has a custom picket railing, guardrail, and an aluminum canopy, all with an anodized finish. The architect went with an anodized finish for its durability in high-traffic areas, resistance to the harsh environment, and the ease of maintenance. This is the UST National Campus in Orlando, Florida. This customized aluminum guardrail and fence has an anodized finish, provide a great look for the stadium with weatherability and long-lasting durability from the harsh Florida sun. Here's a high school in Altamonte Springs, Florida, another example of an anodized aluminum finish chosen for the railings, guardrails, and canopy. Again, the selection of having an anodized finish was based on aesthetics, performance, and ease of maintenance. And one more high school in Florida with a custom aluminum square tube picket railing system that has an anodized finish. Overall, the choice between liquid coatings, powder coatings, and anodized metals for architectural metal applications will depend on a range of factors, including the desired performance and aesthetic properties, the specific application requirements, and the available budget and resources. Each of these coating options offers its own unique benefits and limitations, and careful consideration of these factors can help ensure the best possible outcome for a given project. So let's recap the benefits and limitations of liquid coatings, powder coatings, and anodized finishes for architectural metal applications. Let's start with liquid coatings. Liquid coatings can be customized to meet specific performance and aesthetic requirements. It can provide excellent adhesion and corrosion resistance, and it can be easily applied using a variety of application methods. As for liquid coating limitations, it can emit volatile organic compounds and require special handling and disposal. In most cases, it is not as durable as powder coatings or anodized metals, and it may require multiple coats to achieve the desired performance properties. For powder coatings, the benefits include excellent durability and weather resistance. It does not emit volatile organic compounds and is considered environmentally friendly, and it provides a wide range of colors and finishes. The limitations for powder coatings include the use of specialized equipment and technical expertise in the application process. It is not as easily customized as liquid coatings, and it may not provide the same level of corrosion resistance as anodized metals. Anodized metals provide excellent corrosion resistance and durability. The finish is chemically bonded to the metal substrate for long-lasting performance, and it does not peel, chip, or flake over time. The limitations include the range of colors and finishes that are available. It cannot be easily customized once the anodization process is complete, and it can be more expensive than liquid or powder coatings. Architects embarking on a project must carefully evaluate the benefits and limitations of different coatings and finishes to make an informed decision. Metal liquid coatings offer a wide range of colors and finishes, allowing for creative expression and customization while meeting the highest performance standard with ALMA 2605. Powder coatings, renowned for their overall durability, provide excellent resistance to chipping, fading, and abrasion, making them ideal for high-traffic areas. Furthermore, the powder coating process is environmentally friendly. Powder coatings can meet 2605, but typically are specified for 2604 applications. Anodized finishes, on the other hand, provide exceptional corrosion resistance, ensuring the longevity of the metal substrate. Since anodized metals are finishes and not coatings, the performance standard is ALMA 611. By understanding these distinctions, architects and owners can select the most suitable coating or finish based on the specific requirements of their project. This concludes our AIA course presentation, and thanks so much for your time. If you are looking to receive credit for this on-demand course, or you would like to receive a certificate of completion, you will have to take the required 10-question test and get 80% correct. To take the test, just go to the Continuing Education page on our website, if you're not there already, and click on the Take Video Course Test button. This will take you to the online test. If you miss any questions, you can always go back and correct your answers. Once you have passed the test, you will receive your certificate, and if you are a member, we will submit your completion to AIA. Please allow up to 2 weeks to receive your credit. If you would like any additional information on Greco, you can visit our website at grecoarchitecturalmetals.com or call us at 1-800-363-7245. Greco continues to build its library of continuing education courses, both on-demand and live presentations. If you are interested in any of our other on-demand video presentations or would like to request a lunch and learn presentation, please visit our website and go to our Continuing Education page.